Hi YouTube, I'm Don Phillips, a multi-craftsman. From time to time I put some videos up showing some projects that I have done and the way that I do them. And I don't usually try to express any expertise when I'm doing this because I don't have any expertise. I am sort of like what you call a beginner machinist. I've had 40-something years industrial experience as a multi-craftsman. That's why I took the name multi-craftsman. Everything from electronics, the electrical, welding, all type of machinery repair. But not as a machinist. I think in my past I have turned down a few shafts and I have cut a few keyways. That's pretty much it. So naturally, when I decided I want a lathe, I started watching videos, and Mr. Pete was one of the earliest ones that I stumbled onto. And it was his video that was at the bottom of suggestion videos that YouTube put down, and he was showing how to use a DRO to locate the holes in the hole pattern of a bolt circle. I didn't really have any needs right at this moment for locating bolt circle holes, but it was very interesting to watch, and sometime in the future, I don't really know, I may possibly need this. So yeah, I watched it with a lot of interest, but it didn't really satisfy what the inquirer used to call inquiring minds want to know. I wanted to know how you get the coordinates. He got his coordinates either from a chart or one of these online programs where you enter the size of the bolt circle and you enter the number of holes. That didn't really do it for me. I wanted to learn how to figure out and do the math to find my own bolt hole pattern coordinates. So I did a search on the internet for bolt circles and whatever else I could think of, and I found some that claimed that it did this, but it did not. I found calculators that would do this, I found charts that would do this, and found the little programs on there that you enter certain numbers into them, you know, and they spit out the answers. But I never found one of the videos that actually showed how to do the math to find where the bolt holes were located. And so I didn't get that little anything that satisfied that little itch that I had to know how to do it. But at a time in the past, I did have some trigonometry, and it was way back in the past too. So I decided I was going to sit down and I was going to figure out how to do this on my own, and I did. I sat down with circles, and I draw with holes around, you know, and using some trigonometry, I figured out something that worked. I checked it with 5 bolt hole patterns. I checked it with 6 bolt hole patterns, but I haven't gone any higher than that. But it should work with all. I mean, the math should be the same, just different numbers, different coordinates. So having arrived at this, and I know from reading some of the questions and comments in other people's videos and other programs' videos, that a lot of people wanted to know the same thing that I did. So I just wanted to make it clear that I really have no credentials for doing a math videos. I am not a mathematician by any means. I can add 2 and 2 on a good day. I am not a machinist. So for what it is worth, I'm going to show what I have found on how to do the math to locate the bolt holes in a bolt circle. Okay? That's it. Okay, that should take the shadow out of it, I hope. Okay, I draw a circle and I put a X and Y coordinate in here. This is in red, if it shows up in red on the video. I hope it does. Other than that, the bolts I have drawn with small circles, And one of them, well actually two of them, since this is going to be a 6-hole, this is going to be a 6-hole bolt circle. Yeah, it's a little odd looking through the camera when I'm trying to write. So, anyway, it's a 6-hole, and for to make it easier, we're going to call it a 4-inch circle. It's not actually a 4-inch that I draw, but it doesn't matter. I'm not using programs of any kind to compute. I'm going to do that myself. So anyway, that is a 4-inch circle. So we're going to get on with it. You know, anytime you divide a circle into a number of parts, well, if you decide how many bolts you're going to have, this is a 6-bolt circle. 1, 2, 3, 4, 5, 6. So it actually divides the circle into 6 arcs. And 2, 3, 4, 5, and 6. So if you divide a circle into 6 parts, a circle is 360 degrees. So each one of them will be 60 degrees. If you divided it into 5 arcs for 5-bolt pattern, it would be 72 degrees. You know, divide 5 into 360. If you needed more than that, well, you just divide the number into 360, and the number you come out with will be how much the angle here is. So I got a 60, a 60, a 60, a 60, a 60, and a 60. Okay, and that's 360 degrees. Okay, so now, and I'm going to change circles on you. Okay, back again. So this is one of the things we have to solve is right here. We need to solve how far this bolt hole here is off of the y-axis, which is going to give us an x number. It's actually the same thing as if we went along the x coordinates and we had the line up to here. But I just chose to do it up here. The line here would be exactly the same as this one that I have drawn. Okay, so to do this you need to learn one trigonometric function, and that is sine. You really don't need any other than the sine. You can use cosine, but I'm going to make it simple. We're only going to learn one, and that is sine. And one of the things that makes sine what it is the sine is, am I on the paper? I'm not on the camera. The sine is opposite over the hypotenuse. Man, I don't even know how they abbreviate hypotenuse. We're going to call it the HPO, okay. It's the hypotenuse, anyway. So what is it? If this right here is going to be a right angle. So if we draw a perpendicular from this bolt hole center straight over to, it makes a 90 degrees with this y-axis. Alright, so now you got two other angles, and one of the attributes of the right triangle is that, well, of all triangles, is it has to, all the internal angles have to equal 180 degrees. Don't care what size triangle it is, but trigonometry works with right angles, so we're going to have a right angle here. So if this one here, the right angle is 90 degrees, these other two have to equal 90 degrees, so that they combine, they will equal 180. Alright, let's take a look at the, this is one of our bolt holes, this is one of our bolt holes, and since there's 6 of these, there's going to be a 60 degree inscribed angle right here. So now if this one is 60, this little bitty angle here that is left has to be a 30, because any right angle is 90. So they have to equal 90. So this angle right here is a 30. So to solve what this x value right here is, we're going to have a simple Trigonometric equation, and don't get scared off, it's very, very simple. Sine, what did I say that angle was? 30 degrees. Sine of a 30 degree is equal to, I'm off the paper, not on the camera, sorry. I have to look at the paper to see how to write. I can't really do it in the paper through the lens because it throws it way off from where it really is. But anyway, the sine of a 30 equals opposite. We don't know what it is, but I'm going to call it x since we're solving for an x over the hypotenuse. Okay, the hypotenuse is what? It's going to be a point from the center right here. It's going to be opposite of the 90 degrees. In this case, it's also a radius because we're going from the center to the circle, the most we can go. And for a 4-inch circle, the radius is 2. So the hypotenuse is actually going to be 2. So we got the sine of a 30 is equal to the x over the hypotenuse, which is 2. Okay, one of the things about solving a little equation like this is we want to solve for x. We don't want to solve for x over 2. So we're simply going to get rid of this denominator here. We're going to multiply this thing by 2. And when you do that, the way I learned it in school, it cancels out. So you got x over 1 or you got x, and that's what we want. You do that by multiplying this side by 2. Alright, well when you multiply this side by 2, you got to multiply this side by 2 also. That keeps everything equal. You haven't changed anything. You just changed the way it looks, and it makes it easier to manipulate. So now you've actually got x, forget about the 2, x equals 2 sine of a 30. So I mean, you've got it whipped already. Now all you have to do is get the calculator and punch in sine of a 30. And calculator. Okay, let's see if I can actually get it on here. We're going to punch in 30. Oh, this is difficult on the camera. 30. Should say it up here. 30. And we're going to punch the sine. The calculator is going to do all the heavy lifting for us. The answer is 0.5. So, the sine of a 30-degree angle is 0.5. But we have a 2 times it over here. So 2 times 0.5 is 1. Equals what? X. Well, you know, we just found one of our coordinates. So the x is going to equal 1. Alright, now we need to know our y. So what is the y? Y is the up and down axis right here. And you notice it's not a radius because it doesn't go all the way to the top. It doesn't go all the way to the circle. It stops right here. So there's still a little piece right here. So we have to figure out the length of it to get our y, because this is it right here. This is what our circle is. We can use right here, use cosine, but I don't want to do that. I'm going to use right here, because I told you only had to learn one thing, which was sine. So this one is going to be a 60-degree angle. So how do I know that? Because this is 90, this is 30, and what do we need to make 180? Well, we need 60. So we got an angle right here. So we're going to find the sine of a 60, which will give us the opposite over the hypotenuse. The opposite hypotenuse is what we're going to find. It's going to be the y. Hypotenuse is 2. So, you know, we got it pretty well narrowed down. Let me find a little piece of paper, room on my paper here. We're going to have sine of 60 degrees equal. This time our variable is going to be a y, and hypotenuse is 2. You see why it's 2? Because this is the one that goes from the center of the circle all the way to the circle. And this is what one of our bolt holes. This is the one where we are searching for the coordinates for. So when we do find the sine of a 60, we are going to clear it. We're going to punch in the numbers 60, and we're going to punch in, come on fingers, well, I'm off the keyboard, sorry, sine, and the sine is 0.866. I'm not going to punch in all the other stuff. So we got, I hit the camera, and that's a no-no. You're not supposed to hit the camera. So over here, no, we're over here on this side. We got a 0.866, but because we're getting rid of our 2 in the denominator, so we're going to multiply this side over here by 2, and we're going to lose the 2, which is going to give us a y by itself. But we got to multiply this side by the 2 also, because you can multiply this side by anything. As long as you multiply this side by anything, it don't change nothing. So that's what we're going to do. So now we got 866, and we're going to multiply it times 2, and the calculator says the answer is 1.732. Okay, and that equals our y. Now it doesn't matter whether you say y equals 1.732 or 1732 equals y. I mean the same thing. And you can just flip them over if you want it, what's your way. So now we have found the length of this line right here, which is 1.732. So this is actually our y value. Y is equal to 1.732. Okay, let's see if I can come on down. As we come on down, this is our next little bolt hole, and this is also on the x-axis, so we don't even need the calculator for this one. It is neither high nor low. It is right on the 0 mark, and that's our y. So our y is going to be equal to 0. Our x, well, this is from the midpoint to the circle, so it's the max. It's going to be a radius also. So the x is the radius of a 4-inch circle is 2. So x is 2, y is 0. So man, that was easy. We just move right on here. Now as you come on down to where our other little bolt circle is right here, you'll see that we're going to be dealing with the same 30-degree angle and 60-degree angle. As a matter of fact, this circle, this triangle right here is identical to this triangle right here. So when you solve your equation to find out how far it is this way on the x-axis, it's going to actually be the same as this one up here, but we're going to go through it and work. So we're going to find our opposite over hypotenuse, which is going to be the sine of a 30. Opposite, the sine is going to be 30 over x. The hypotenuse is 2. So when you solve that, it's going to be the sine again over 30, and when you do that, it's going to come out 0.5 just like it did before. When you clear the denominator over the x, under the x, it's going to leave x by itself, so you're going to have 2 times the 0.5, which is going to be 1. So the distance on the x-axis from here to here is going to be 1. So your x-coordinate here is going to be 1. Alright, y. We're going to swap angles to keep using the sine instead of having to use the cosine, so we're going to use this angle. Well, it's going to be 60 just like the other one, because this is a 90, it's got to equal 180, and this is 30. So I mean that's 120. What do we need to make 180? 60 degrees. So now from this angle we're going to get the sine, which is the opposite over the hypotenuse. The opposite this time we're going to call it y. The hypotenuse is 2. So we've already done this one time. We actually don't have to do it anymore. I mean, this is it. We cleared y, the opposite over the hypotenuse, which is y over 2. You're going to multiply both sides by 2, and they're going to cancel out, leave y by itself. You're going to multiply 2 times the 60. I didn't even show it here. But anyway, we're going to do this one. And get the calculator. I'm going to clear it. Let's see, does that clear it? Yep, we got 0 up there. I can't get it no closer hitting the bipod, the tripod. Anyway, when we clear it, it's 0. Now we want to 60 degrees. Let's see, can I punch it in here? Let's see if I move the camera back enough to get the calculator in there. Get the light on it. Oh lordy. Okay, there it is. There's the old 60. Put my needle. One of my legs fell out. Alright, that's the 60. Now we want to find the sine, since that's the only one we're using is sine. There it is right there. The sine over 60 is 866. Forget about everything else. So when you get the dot 866, I'm not on it, am I? So we get the dot 866. Since you have this 2 over here, you got to multiply the 2 times it. So when you multiply 2 times it, you're going to get 1.732. Well, isn't that the same number we had before? Yeah. 1.732. Yeah, it is. It's exactly the same. So actually, we didn't even have to solve this triangle. When we solved this one, we had the whole thing done right there, because this one here is exactly the same as this one here. That's because every little arc is exactly the same. So the angles are going to be exactly the same. So really all we have to do is determine the little plus and minus signs that come in on this thing. If we look at it, everything above the x-axis as far as y is concerned is positive. Everything below the x-axis is the y is going to be negative. You look at the x-axis, now everything to the right of the y-axis is going to be positive. Everything to the left of the y-axis is going to be negative. So since we are solving this problem, the x is over here. So it's over here to the right, so it's going to be positive. We found x to be 1. Y, we found y 1.732, and I don't have it on this one, but the y is negative because it is below the x-axis. Now actually on my DRO, it shows the y coming down this way has been positive and the y up this way is negative. That can be changed, I believe. I just really hadn't learned to use that DRO as well as I need to. But hey, I'm a work in progress, you know. But anyway, you can do the same thing with all these other ones. You're going to still end up with the same numbers. You're going to end up with x as being 1 right here. Once you solve this triangle, it's going to give you the same value for x as we had up there. It's going to be x, and besides, it's to this side of the axis, it's going to be a minus 1. And we're going to solve for the y, and you're going to see that this the length this way is going to be your Y value, and it's going to be 1. I'm going to get it in there. 7, 3, 2. And because it's below the x-axis, it's going to be a minus. Now when you move up to this one, obviously it's on the x-axis, so I mean this one here is the easy one. The x value is going to be maximum, it's going to be a radius, it's going to be a 2. And it's going to be a -2 because it's this side of the y-axis. Now the y is neither up nor down because it's on the center line, so your y is going to be 0. Okay, so now here we have a triangle. Can I zoom in anymore? I always go the wrong way. Okay, we're going to have this triangle right here, and it's going to go straight on over to make a perpendicular out of the axis here. And if you solve this one using the this right here, from this bolt hole to this bolt hole, did I have it in there? It's going to be the, no, that's, did I even have a circle in there? Huh? Anyway, I have it a little bit, I've drawn it a little bit too far, but it don't matter. I did all this by hand. Anyway, it's going to work out exactly the same. The x is going to be 1, and the y is going to be 1.732, just like we had. Now all we got to do is get our signs. So anyway, this video is dragging on kind of long. It's going to probably run over the 20 minutes. But basically, and I'm sure once somebody sees that I'm showing how to figure this out, they'll improve on it and show it in a much better way than I just did. But anyway, have fun doing it the hard way. Hey, Martha Craftsman, hey, we out of here.